Okay, so by my watch, it's the appointed hour. So good morning, good afternoon, good evening to everybody, wherever you are today. And welcome to the seminar, or the webinar, I should say. Today's topic is process safety, why it's important to consider more than one life cycle. So, just by way of introduction, I will explain a little bit about Exida. Some of you may know Exida, some of you may not. So for those of you that don't know Exida, I shall just give you a quick overview of the company. We've been around for 20 years now, and we primarily started off as a certification body doing certification of products for IEC 61508 compliance. Since then, the company has grown rapidly and expanded, and we do more than just certification now. We cover both the product certification, personnel certification, as well as providing services for alarm management, functional safety, and cybersecurity. We also now do cybersecurity product certification. To support all of that, we have a suite of software tools which is very comprehensive to support the life cycles. We're also global. We started off in the US and Germany, but we've rapidly grown, and we deal in different markets around the world: oil and gas, automotive, petrochemical, chemical, utilities, etc. And how we measure our success is by looking at how far we've come in the 20 years. Originally, it was owned by two founding members, the company. Now it's mostly employee owned, and every 2 out of 3 devices certified today have been certified by Exida. And we've got more than 100 people, global experts worldwide. We've done over 1,000 certification assessment projects. And we've also modeled over 500,000 CIFs with the Excellencia suite. Reference materials. Now, I always encourage people to utilize our website, because all these webinars that we do are recorded and they are available through the website. If you go to exida.com and look under the resources tab, there are webinars that have been done on automotive, robotics, functional safety, machine safety, alarm management, cybersecurity, certification. So there's a whole wealth of information there. And all these webinars are recorded as little YouTube videos, so you can basically play them back at your leisure, and there's no charge for doing that. And these are very useful. Also, there's books you can get. So from the website, you can purchase any of these books that you see here. And certainly the SERH, which is our Safe Equipment Reliability Handbook, has all the failure rates for all the devices. And this, of course, is built into the Excellencia tool. There's also the SAEL, which is available through the website. And when you go to the home page of exida.com, in the right-hand corner at the top, you'll see the Safe Automation Equipment list. And that will show you all devices that have been certified, and you can view the certificates, and if we're allowed to publish it, you can look at the assessment reports as to how the numbers, the failure rates were derived, which is a very important thing to understand. So again, lots of information available through the website, things that you can get for free, things that you have to buy, of course. We're not a charity, but we do a lot of free work as well. A little bit about me. Those of you that don't know me, I've been around in industry now for 42 years, and my background is in safety and controls. I came to Exida about seven and a half years ago now, and my role is primarily to manage our services business, but also to look after the training, and I'm one of the primary instructors for our FSC 100 course. Also, I've published some papers. Again, these are available through the website. You can get them at no extra charge. Of course, there's the Just go visit the website, you'll find most of these. And that's really me and the company. So let's get down to the subject at hand. So, process safety, why is it important to consider more than one life cycle? Well, most of the time, if we just remind ourselves, process safety, and people still get process safety confused with personnel safety, but process safety is all about dealing with the things like toxic releases, explosions, and the fires that are associated with operating hazardous process plants. And obviously what the goal of process safety is to make sure that we can manufacture whatever product we need to manufacture as safely as possible. So obviously hazardous processes require some form of risk management to help prevent and or mitigate these effects of having an incident, a loss of containment, an explosion, a fire, etc. And unfortunately, as hard as we try, we still don't seem to be able to prevent accidents for a variety of reasons. So process safety is separate from personnel safety. Obviously, it involves personnel safety, but personnel safety refers to hard hat faults, what's known as hard hat faults, the slips, trips and falls, whereas the process safety is much greater in terms of the impact. So, having reminded ourselves of what process safety is all about, then we need to think about, okay, so we have to have some form of risk management. And again, as obvious as it may sound, why do companies manage risk? And very simply, the companies manage risk because we have a legal, a moral, and a financial obligation to limit this risk that's posed by the operation. Of course, from a moral point of view, we should make the plant as safe as possible, irregardless of costs. The financial view, of course, is that we need to build the lowest cost plant and keep operating budget as small as possible and keep costs to a minimum to maximize availability, the uptime, and of course the profit. And then the legal side of things is, of course, that there are regulations that we need to comply with. And of course, depending on where you are in the world, the regulations will be different, but similar. For example, in the US, if you are a plant that stores more than 10,000 pounds of highly toxic, volatile or corrosive material, then you come under OSHA Process Safety Management, CFR 1910, CFR 29/1910, I should say. And then, of course, in the UK, on Europe, there are COMA regulations, and the HSE is very strict in the UK, and so they obviously define requirements as well. So we have to balance this, of course, and that's the whole point. The whole point is to get to an acceptable level of risk that's acceptable in not only in terms of societal standards and the standard of care that we're trying to achieve, but also in terms of balancing the cost requirement with the legal requirement. So companies need to look at how this is expressed, and it really comes down to the culture again of a company. And those that have been on the FSC 100 course and heard me preach this so many times, that culture has to come from the top and has to come from top management. If the culture is not there to support doing or implementing process safety correctly, then it's going to be very difficult for the troops on the ground, as it were, to be able to follow and maintain the standard of care. So it's important to understand how a company looks at this and then to develop these policies that's consistent with the way that the company works. So there needs to be a cultural balance to all of this. So that's really why we have to manage risk. So if we now look at when it comes to process safety, where's the current focus? And of course, most companies in the process industry and in most industries that have hazardous processes, they focus on compliance with what's known as RAGAGAP, recognized and generally accepted good engineering practice. Most of you have probably heard this expression. It's sometimes called best practices, and of course, IEC 61511 is or provides best practice for process industries. Now, here again, this is where the focus tends to be. Now, in 2016, of course, the IEC 61511 standard was changed to include cybersecurity. So now we don't just have the functional safety requirements to think about. We have to consider, when it comes to the safety instrumented system, the cybersecurity requirements. But again, what's happened there is, okay, that was 3 years ago, and some companies have started to look at this and think, okay, we should be considering cybersecurity now for not just the SIS, but also for the control system, the basic process control system. So the whole process layer, if you like, the operational layer, should be looked at. So companies have been, some have looked at it and started to take steps to follow this and adopt it. Others have been reluctant to do this for a number of reasons, and some are doing it but very slowly. Now, the other part of the equation, of course, is that alarms. Certainly if you're taking credit under IEC 61511 for alarms, then for an operator to respond to an alarm, then the operator certainly has to have an indication of that alarm. He has to be trained in what to do when that alarm occurs, and he has to know what he needs to do. And thirdly, he has to have time to do it. He has to have enough time to be able to implement that. And herein lies the problem. If there isn't a proper alarm management approach, following the alarm management or the alarm cycle, life cycle, what happens is that you could end up with, under process upset conditions, you can end up with hundreds of alarms coming in and confusing the operators, and in some cases paralyzing them. There's documented evidence from accidents where operators, for example in Buncefield in the UK, the operators were paralyzed really for about 15 minutes or so because they couldn't figure out what was going on. So again, if we're thinking of considering alarms as a protection layer, then we have to make sure that we have properly defined, prioritized and rationalized alarms. So this means really we should be looking at all three life cycles: the functional safety life cycle, the cybersecurity life cycle, and the alarm management life cycle. Otherwise, we're not really considering all the risks, and we're not properly containing them. So if we look at this from an operational landscape point of view, as you can see, in terms of what binds these together, we, for example, will have consequences if there's a failure in the alarm system, if the operator fails to see the alarm because you can't see the wood for the trees. So there's a consequence of inaction, which is caused by a deviation. So the process has gone out of normal cycle and there's a deviation, there's an alarm, but the operator doesn't see or can't figure out what he needs to do, and there's some sort of consequence associated with that inaction. From the safety instrumented system point of view, of course, there are consequences of failure on demand. And we all know that in the process industry, when we talk about looking at safety instrument systems and safety instrumented functions, we're looking at either the probability of failing dangerous as an average, the PFD average, or we're looking at the probability of failing per hour. And of course, the PFD average applies to low demand CIFs, and the PFH applies to high demand and continuous. So we all know what happens with, and if you remember the Swiss cheese model, when all the holes line up, then we have a problem. So there will be consequences of failure on demand that we need to be able to address and mitigate against. Then there's consequences of compromise. So you can have a very robust process control system, a BPCS, and an appropriate SIS installed. But if they're connected on the network and the network is compromised such that both the BPCS and the SIS are prevented from doing their normal control function and safety function, then there's going to be consequences of that compromise. And here again, if you want to think of it this way, cybersecurity can be the mother of all common cause, because it can take out redundant systems, it can take out any electronic system if it's got some form of communication or programmability. So we have to be very careful with cybersecurity, and that's why, of course, there's more emphasis placed on the need to be diligent when it comes to cybersecurity. So within that, of course, you can see there are overlaps between these. And the other thing, of course, that from an operational point of view is what we have to do is in terms of the SIS, the safety system, is that we need to have devices that are reliable. And we know from 1511 that we have two methods to be able to do that. One is to use 1508 certified devices, and the other is to do or have prior use justification for the use of the devices. So this will encompass the reliability. Then, of course, we have the people part of it. We have training. We have to make sure that our people are properly qualified and trained and competent. Here again, one of the changes that was made in the IEC 61511 in 2016 was more emphasis on competency, roles and responsibilities, so that we ensure that we have properly qualified people that are trained to deal with the systems and any deviations. So again, what encompasses all of this? As I've said already, culture. If the culture isn't there, if there isn't the right support from upper management and the recognition that we have to do this correctly, then of course it's going to be very difficult to implement properly. And that will then add additional risk. So it's important to understand that. And there are interdependencies clearly between them. You can see that here are the standards that govern each of these. 62443 covers the industrial automation control system from a cybersecurity point of view. 1511 deals with the SIS and the cyber aspects associated with that. Of course, 1508 and 62443 deal with the device certification, so that if you have intelligent devices, you can have them certified not just from a safety perspective, but from a cybersecurity perspective. And then personnel, you could have personnel who are competent and they've been qualified. They're a CFSE, a certified functional safety expert, or they're a controls automation cybersecurity expert. And then we have the alarm management, which is the IEC 62682 or the ISA 182. And then policies and procedures and tools. So these touch points are where we can make use of policies, procedures and tools to make sure that nothing falls between the cracks. So the other point is that there needs to be a practical implementation of this, because again, we have to be successful on this, we have to have a thoughtful approach. And this is where we here at exida, we talk about taking a pragmatic approach. Because again, it has to be balanced with what the company is trying to achieve. What are the goals? So simply complying 100% doesn't guarantee reaching a particular goal. So you need to understand the overall structure and tailor these processes to meet the site needs and capabilities. So again, if the site doesn't have a very strong culture, then it needs to be, you're only going to be able to achieve a certain amount, and so you need to recognize that. The other thing, of course, is we need to make sure that we have the correct metrics in place to be able to determine whether we're achieving our goals or not. And again, coming back to my point about culture, you've got to have the right culture. There needs to be buy-in from management to support these 3 life cycles if we're going to be successful in implementing process safety. This means that we need to develop an open and learning culture. So in other words, we want to actively encourage people to learn from mistakes, not punish them. Learn from mistakes, but also have some autonomy so that if they think something is unsafe, if there's a potential for an unsafe process, then they should have the authority to be able to shut things down. So that takes a lot of faith and in your employees and your staff and in your processes and procedures. But you've got to develop that open and learning culture so that people are not afraid to speak up, they're not afraid to take action. So that means doing things right and also doing the right things. This is what it comes down to. So, for example, we have to make sure that our O&M people are properly trained and that they follow procedures. There's been several accidents where operators bypassed or rather they didn't follow startup procedures properly. So again, if they don't follow the procedures, there's no point in having the procedure. So the procedure needs to be correct and it needs to be followed. Making use of metrics and documentation is very important. We need to be able to record and be able to show that we're doing the right things. And again, if it's done right, of course, it will save time and money. This is always a conversation I have with management about if you do it right, it saves you money because you have less downtime. So if you're not following procedures, if you're not doing your mechanical maintenance and integrity properly, you could end up having more equipment failures, and those equipment failures could cause you to have unnecessary shutdowns. So downtime is expensive. Not only that, you have to start up again, and that's when things can be very dangerous. Most accidents happen either during maintenance or startup. So effectively, it is a long-term investment, but there are short-term gains because if you tighten up your procedures, if you make sure your people are properly trained, you'll probably have less mistakes and you'll have less downtime. So if we look at all 3 life cycles, we can see that they basically have the same 3 elements. There's some form of assessment phase for identification, so the hazards from the safety, the threats, and the vulnerabilities from the cybersecurity, and of course the assessment of alarms from alarm management. Then there's some form of design phase to design a solution, and of course then there's operation and maintenance. So there are 3 common phases for each of these disciplines. And of course, the glue that holds it all together is either the management of functional safety, alarm management, and cybersecurity. So we need to make sure that it's the usual, identify, plan, act, review, and adjust. So if we look at each one in turn, 1511, this is owned by engineering, process, safety, and operations. So there are the 3 phases, the identified phase, the analysis phase as we call it, indicated by the yellow boxes, design and implementation or realization indicated by the pinky red box, and of course operation and maintenance, the grey box. So again, the scope in this case is the analysis of the process for inherent risk, and then the design and implementation and maintenance of these safeguards to protect against the hazard scenarios. In other words, our safety instrumented system and our SIFs. We come to cybersecurity, you can see the same thing. So in the assessment phase, what we're looking at is identifying where our potential vulnerabilities are and what the threats are. Now this requires cooperation between what's known as operational technology, OT, and information technology, IT. So IT deals with the corporate-wide LANs and WANs, all the email servers, all the main data capture. And there's a difference between the priorities set by IT versus the priorities set by OT. IT, they look at it from CIA, which is confidentiality first, integrity second, availability third, whereas OT looks at it as AIC. They're more interested in availability to make sure that the system is operational. Then they're looking at integrity, and then finally confidentiality. So they're diametrically opposite from each other, but they have to work together as a team. And so the scope here includes the assessment of the facility from the point of view of risk, and then the subsequent design, implementation, and maintenance to protect against those process and business risks due to the cyber. So the IT is going to be worrying about the business risks, the OT is going to be worrying about the process risks. And again, you can see the same three phases. When it comes to alarm management, this too is owned by engineering and operations. And again, you can see there's an identification, then there's rationalization of these alarms, and then we design an alarm system that will be followed by operation maintenance, and that it will be managed. And typically what this requires is some form of philosophy from the point of view of what the company deems is what they consider to be alarms, the priorities of those alarms, and how they deal with it. So those three all come together. And the thing about these three is that they are performance-based standards. They're not prescriptive. So therefore, it means we need to be able to measure performance to see whether or not we're actually maintaining the original design parameters, and we're still achieving the amount of risk reduction that we were looking for. So we have to look at this to be able to measure the performance of all these three when applied to the SIS and BPCS applications. So this means we need metrics or key performance indicators, KPIs. And one way of doing this is you can use leading and lagging indicators. Some of you may have attended the webinar I did on leading and lagging indicators, but if you didn't, it's recorded, so it's on the website. There's also a paper on it. But essentially, lagging indicators are indicators of things that have already occurred. So if you've had incidents, if you've had near misses, if you've had trips, if you've had faults, etc., you should have those recorded. And the leading, because what we want to do from the lagging is be able to learn from that and reduce the occurrences if there have been. The leading is looking at how often are we doing assessments, how often are we training our people, how often are we doing our testing and mechanical integrity, and are we doing it within the original requirements of the SRS, Safety Requirement Specification, or the CSRS, the Cybersecurity Requirement Specification, or the Alarm Management Requirements. So we need to choose those metrics that we can rely on and that will help us to be able to prove whether we're meeting target or not. And again, just to remind ourselves, there are clear interdependencies between them. And these standards all have requirements and guidelines on what to do. So from the functional safety point of view, what we need to be able to measure is some of these key parameters that were defined. So when we do the original design and the SRS, we have defined proof test intervals. How often are we going to be testing our safety instrumented functions in our SIS, and therefore what duration is there, the efficiency in terms of the coverage, are we achieving the coverage, and then the spurious trip rate. The spurious trip rate is important because we have to define that, and we have to make sure that we don't have spurious being unwanted trips. So we should be recording any of those. And then we need to look at the mean time to restore was also defined. This is the time taken from if we have diagnostics or if we find a fault during proof test, how long does it take to fix the fault and to restore the SIF to normal operation. There are also O&M personnel assessments. So again, is the training being conducted? Are regular assessments being done? Because one of the other changes in 1511 in 2016 was that there needs to be regular or periodic, as it calls it, personnel assessments for O&M. And how often are audits being conducted? So these are all things that are important to be measured, because with the training and the audits, those are leading type indicators, because it'll give us an indication of if we're more or less likely to have an incident in the future. Obviously, if we're not training or doing assessments of our personnel, we run the risk of somebody making a mistake that causes an incident. If we're not doing audits, then we don't know if we're documenting everything properly, if we're following procedures like we should be, etc. And then these events need to be recorded. So any demands on the SIS, whether they're real or false, any incidents or near misses. So of course, if relief valves go off, that's an indication that all is not well, and we should be looking at that and tracing that to root cause. Failures, both random and systematic. Those of you that have been on the course know that systematic is all about the 3 Ps, which is people. Are our people properly trained and competent? Otherwise, if they're not, they can make mistakes. And then procedures, are they following procedures correctly? And then the paperwork. Do we have a paper trail to show that we're doing all of this? Proof testing. We need to record proof testing and the results of proof testing and make sure that we don't go outside of the period between proof tests of more than 10% at the time. So, for example, if the proof test interval was defined as being 18 months and it's taking us 24 months to get to the proof test, that will have a significant impact on the SIL for our SIFs. Repair and restore times, they need to be within the MTTR, the mean time to mean time to restore, specified in the SRS. Maximum permitted repair times. Again, now 1511 requires us to define that so that if we're doing online repairs, we don't leave the SIF in bypass for more than a specified period of time. So, for example, if we've set our time as 72 hours, then we might say our maximum permitted repair time is 100 hours, allowing for delays in getting spares if they're not on site, etc. And of course, procedures not being followed properly. So these events would need to be recorded. From a cybersecurity point of view, we would be looking at, have we had any incidents, whether they're accidental or deliberate? So most of the time, if the installation isn't an attractive target to an outside hacker, then it'll be internal, and the internal will be split between what we call the stumbling, fumbling, and bumbling, or deliberate. So the disgruntled employee. So again, if we've had incidents, we need to be recording those and then looking at how did they occur and how could we have prevented it. We should be doing periodic vulnerability assessments. So it's not a once and done. You should be going back periodically to look at, okay, are our countermeasures still good? Do we have any new potential vulnerabilities? Have there been any policy violations? Because again, if you have policies and procedures, so for example, if there's a policy on not using portable media or not plugging in thumb drives, if somebody's doing that, then there needs to be some form of follow-up. Are we doing training and personnel assessments? And if so, are we doing them within an acceptable period? How often are we patching and introducing antivirus updates? Are we doing that according to what we defined? Cybersecurity audits or assessments, are we carrying out these periodic reviews or for changes and updates? So all of those need to be recorded. From the alarm point of view, are we getting any nuisance alarms in terms of stale alarms, chattering, and do we have top 10 bad actors, for example? So those need to be recorded, as well as the number of real alarms that occur. And then what are the average number of alarms per operator? Here again, the standard defines the operator shouldn't have, or an alarm shouldn't be generated any more frequently than once every 10 minutes. So if there's an alarm flood that occurs due to a process upset, then what percentage of time are we in the flood condition? That needs to be recorded. So, performance of individual safety alarms. Although the SIS won't be generating alarm for the operator, it needs to generate, if it's called upon to trip or to take action, it should be reporting this to the event log or the historian. So again, what is the alarm rate? How often is the alarm layer challenged? How much time in alarm? What's the average time from enunciating to clearing it? And again, what about stale alarms? This is the time that the alarm is not available. So again, need to think about this because the system and individual alarm performances have to be acceptable, or our safety alarm cannot be considered effective. So these are things to consider. And then if we look at putting it all together, so there is a need to understand these interdependencies between functional safety, alarm management, and cybersecurity, because again, they're all potential risks if they're not done properly, and if we do them properly, they will help ensure process safety and risk is properly managed and maintained within these acceptable levels. So you need to understand the overlap and the interaction between the three life cycles. If we do that, we will be able to enhance performance and efficiency. Having the right culture is vital, otherwise the success will not be guaranteed. And then making sure that we have the right set of metrics for each of the three to be able to measure and assess performance is very important. Because otherwise we won't know whether we're achieving the goals that we set. So from the cyber point of view, do we have the right countermeasures? Are they being effective? And then from the safety point of view, of course, are we doing the testing correctly? And is it effective? And from the alarm point of view as well. So we need to also think about how often employee competency assessments need to be done. And again, having an employee that knows alarm, cyber, and functional safety may be a bit of a stretch. So you may have different employees, but they do need to have their competency regularly assessed, or at least they need to be assessed to make sure they know what they're doing. We need to record all the maintenance activities accurately and faithfully, because we should be able to use this information during PHA revalidation. So when you're doing, for example, in the assessment phase, when you're doing a PHA from a safety point of view, you can also do a cyber PHA, because you can look at the potential cyber hazards and threats. And then when in safety, when you're considering the mitigation, you're considering the countermeasures in cyber. Same thing. From the alarm point of view, we're looking at what potential alarms will come out of the PHA and the LOPA. So you can start building a master alarm database. So this provides you with efficiencies, because if you do it at that point, then you don't have to do it again later on. You're doing it during the PHA revalidation, the 5-year period. And that's something that will help in gaining some efficiencies. So that's it. There's, just so that you know, on October the 2nd in the UK, we are going to be holding a seminar where the seminar topic will be going into this in more detail and talking about maturity and the life cycle. So if you want to know more, please contact us and we can give you details. Ali Coles in our UK office can provide all the details. If you have any particular questions that you don't want to ask me now, you can certainly ask me through email. So I shall open it up to questions. Any questions? No questions. So one question. Okay, how do we get started? Well, the easiest way, if you want to look at the 3, is to do a gap. And that can be done fairly simply, where we can look at what you're trying to achieve, what the goal, and look at where you currently are and what you need to do from a pragmatic point of view to get things started, to move along this line of integrating these 3 life cycles. And again, if you want to know more, just drop me a line. But it is relatively easy to get started, and the gap is the best way. Anybody else? Any other questions? No. Nobody has any questions? Okay, well, in which case then I thank you all. Oh, there's something's popped up. If the SIS is not connected to the rest of the world with the internet, then, well, you know, that's we get that all the time. Even if you're not connected, you still have means of programming the SIS. You still have some engineering workstation. You will still have some form of RJ45 ports, etc. So you have to make sure you do a vulnerability assessment. People say to me, well, I'm air-gapped and I've got antivirus, so I'm golden. No, you're not. Antivirus at the best of times is only 35–40% effective, because antivirus uses blacklisting and you can't cover, I mean, the rate that these hackers and these people are coming up with these viruses and malware, you can't possibly keep up. But the point is, you will still have vulnerabilities, so you still need to do an assessment. You might not have as many, but you're going to have some. So don't think that because you're air-gapped, you're golden. Okay, there's another. Procedures can be in place not to use any ported devices. Yes, procedures can be in place, but again, you still have to make sure that you harden and that there are other things that are done, because you've still got to program it. And there will be an engineering station. The engineering station will need to be locked away. You will need to make sure that you have taken as many precautions as you can. But again, just because you're air-gapped doesn't mean that you're golden. Any other questions? Those are good questions, by the way. Okay, well, with that then, if there are no more questions, I thank you all for attending. If you do think of anything else, there's the email address down here. Drop me a note. I'm always happy to answer questions after the webinars and follow up. So I thank you all and wish you a very pleasant rest of your day, and look forward to you attending a future webinar. Thanks a lot.